And there's a very famous phrase, let there be light, and lots of famous pictures and things have been done about that, trying to explain all about light. And we're going to start a little explanation with this video. Hopefully we'll get some useful information out of it. So light, where exactly does it come from? So we get it from sources of light. All these things here are different sources, and you'll recognise most of them. You know, the lampshade, the sun, electronic devices, candles, chemicals burning, and the torch coming from batteries. They're all making light in their own sort of way. So let's have a closer look at some of these sources of light. That's the only place you're going to get it, from a source of light. So what have we got? Yep, source of light makes light. Oops, go back one. So there's the sun. It's a star, and it makes our light for our planet here. As Earth rotates, we have daytime and nighttime. But the sky is filled with stars, and these are spaces, sources of light. But here on the planet we also have sources of light as well. Fire is a source of light that was first used by our ancestors many thousands of years ago. We now make our own light using chemicals and batteries to create light. And bulbs that glow, fluorescent light bulbs or filament light bulbs like these ones, incandescent ones, which aren't very good. They actually produce more heat than light. And now the modern LED light bulbs as well. Fireworks also make light using chemicals that all produce their own various colours, and I enjoy a good fireworks show. So let's see some more fireworks. All to do with chemistry. So if you enjoy chemistry, perhaps you'll be good at making fireworks. More chemistry. This is luminescent fluids of various colours. Once again, chemistry releasing light. So there's sources of light. And lasers, a more recent development on the light bulb kind of thing. A very sort of coherent, coordinated type of light. Depending on what it's been used to spark off the laser, what colours we get. And some are used simply as pointers, others are more powerful, as for example here, being used to cut steel, etc. So light has a lot of energy within it if we can use it to cut things like this, if we can get it organised. And energy in lightning as well. So light is all around us in various forms. What else can we figure out? Okay, so there's light in nature as well. So some animals like the fireflies. Now I'd never seen a firefly until recently. I was on a trip to Vietnam and sitting in the evening in the village where we were staying, and there's this flashing lights in the sky, and lo and behold, fireflies. I loved them. That's the neatest little beetle buzzing about. And this is a picture I found on the net, but I haven't seen, didn't see anything like this, a whole tree full up with them lit up at night. So they use the light to attract other bugs that they eat, but it just looked wonderful, this flashing light flying about at the night sky. Here where I live in New Zealand, we have a little animal that makes its own light, a thing called the glowworm. And it doesn't look very pretty, but if you think about it, it spends its whole day lying in a silken hammock. And if we look at the picture here, there's the beast lying in its hammock there, and it has these strings that it lowers down from the hammock, and on the string there's little wee bubbles, and they're sticky fluid that it uses to catch its prey, and the prey is attracted to, of course, the light that the glowworm is putting out. So it spends its whole day lying in a hammock made of silk fishing. What a wonderful way to spend your day. Imagine that, lying in a hammock fishing. Get enough of them together and they can look like the night sky. See them in caves, usually near the entrance where there's lots of airflow, bringing lots of bugs and beasties in for them to catch on their strings and reel in and munch on. And here's a little poem. I wish I was a glowworm, because glowworms are never glum. How can you be unhappy when the sun shines out your bum? So yeah, think of a glowworm hanging around all day in a hammock fishing. What a way to go. Righto, what else we know about light? We've already met some stuff about light in the previous video clip about waves, and that's where we get here as well. Light is a wave of energy. Okay, like the waves in the ocean, when you stand in the water, the wave comes and hits you, you can feel the energy in it, and light also carries energy. Now, in light, if we vary the wavelength, we get different amounts of energy out of it. And this light, this wavelengths of light, helps grow plants. They use it to do what we call photosynthesis, trigger off chemical reactions inside the plant that produces the oxygen that we breathe and the energy that goes into a lot of the food that we eat, or the animals that we eat that eat plants. So the sun is a sort of source of energy for us. And we also can use the sun to produce electric currents. We're seeing that more and more with solar panels on roofs of houses. And as I said, we change the wavelength. Okay, that's the part of the wave up here. So between the two peaks here, we make that longer or shorter, and that will vary the amount of energy that the wave of light carries, which has an interesting effect for us. Because wavelengths, as it says, it's a secret to the rainbow. So you get a rainbow in the sky, and we see all these different colours from all the different wavelengths of light, each of which carries its own level of energy. So visible light is made up of all these different colours, giving us the word Roy G. Biv, the red, orange, yellow, green, blue, indigo and violet. For all the colours that we can see, our eyes detect this wavelengths of light. And now you've probably heard of what's called ultraviolet or infrared. Well, at the top of the wavelengths here, we've got red. If we go this way, we get longer wavelengths of light, longer wavelengths here, and we get infrared. If we go the other end and go that way, we get shorter wavelengths of light, the white peaks are closer together, and we get ultraviolet light. You can't see them with your eyes, but you will feel it. The infrared, you'll probably detect that most of some of those bathroom heat lamps, because that's what we feel as warmth on our skin. Ultraviolet, you may not feel it as much on your skin, but you'll notice the effect, because ultraviolet light is what triggers sunburn. So we can't always see the light if the wavelength's long or short, but we can detect it other ways. But those main colours there are the colours of visible light. And then light does these things, reflection and refraction. And that's what we're going to look at in another video. So I hope you've got something out of that, looking at light and what triggers it. And thank you for watching.